Welcome back, my dear students. Already in last class we have discussed about motion. There we have discussed about what is rest and what is motion. Then after that we were seeing some examples of different types of motion. Today we are going to discuss something more about this chapter. First one, we are going to discuss motion, uniform and non-uniform. What do you mean by uniform motion and non-uniform motion? So I think already I have explained there in the last section what is uniform motion and non-uniform motion. What is motion? Motion means if an object is traveling from one point to the another point, this is called motion. Okay, so when we are calling this motion as a uniform motion, the uniform motion means if the object is traveling same distance with the same interval of time. If the object is traveling same distance in same interval of time. For example, if we are considering a car is running from A to B, suppose if it is covering 50 kilometers in 1 hour, the next hour also it should cover another 50 kilometers. So a uniform motion means if the object is moving with the same distance in same interval of time. This is called a uniform motion. And what is non-uniform motion? Surely unequal distance will be covered with the equal interval of time. Unequal distance will be covered with the equal interval of time. For example, first hour it will be covering 50 kilometer, then in second hour it will be covering maybe 40 kilometer, then in third hour it will be covering sometimes 60 kilometer. So like that, if the distance traveled is varying with the same interval of time, then we will say that it's non-uniform motion. Then another two regarding this motion, two important topics or the terms we are going to consider is distance and displacement. Distance and displacement. What is the definition of distance? Distance is the actual length covered. Actual length covered. Whereas displacement is the shortest possible distance covered by an object between initial and final position. Okay, distance is the actual length covered, whereas displacement is the shortest possible distance covered in between initial and final position. For example, I am considering an object or placed at A, and this is I am going to travel. This is another point B. One boy is going to travel. Maybe he is going to take a path like this. A path he is traveling and he has reached into B. So actually this is called a distance. Actual length covered by this object is called a distance. Whereas displacement is the shortest possible distance. What will be the shortest possible distance? This will be the shortest possible distance. So the shortest possible distance between initial position and final position. This is called a displacement. Sometimes we can say that like this one path also can be followed. This is also called a distance, not a displacement. So for one particular body, maybe displacement will be one quantity. Sometimes if it is moving 20 meters, sometimes this will be moving 80 meters. But 80 meters is the distance. And actual distance, the shortest distance between them are 20 meters. So that will stand for displacement. Okay. Then again, we can say that displacement for this triangular shape. For example, one body is traveling from A to B, then B to C. Okay. So if it is traveling to A to B, suppose if it is covering 6 kilometers, and here if it is covering 8 kilometers, then the total distance traveled by this one will be, what will be the answer? 8 plus 6, total 14 kilometers. So distance traveled will be 8 plus 6, 14 kilometers. But whereas displacement is the shortest possible distance between this was the A was the initial position and C is the final position. We are not considering B. So the shortest distance between A and C, how we can calculate, will be equal to, we have to find out this side. This side will be equal to, AC will be equal to root of AB square plus BC square. In mathematics you have already used this equation. So 6 square plus 8 square, there you are going to get 100, that means 36 plus 64 you will get 100, root 100, that will be equal to 10 kilometer. So 10 kilometer is the displacement here, whereas 40 kilometer is the total distance travelled by an object. So these are the two different important terms regarding motion, distance and displacement. Again, we are moving to the next one, scalar and vector quantities. Scalar and vector quantity. Okay, what is scalar and vector quantity? Already, I think in class 6 we have learned about how we are expressing the terms. Suppose if I am traveling 10 kilometer, for example, 10 kilometer I have traveled. 10 kilometer, 10 is the magnitude and this is the unit. If I am considering only magnitude, then that quantities are called scalar quantities. And if I am considering along with the magnitude, if I consider direction, then I can say that this is vector. For vector quantity, I will be expressing like this: 10 kilometers saying towards east. Direction will be given. Okay, so this is called scalar and vector quantities. Scalar quantities means the quantities which are expressing only magnitude, whereas vector quantities are the quantities which is showing both magnitude and direction. So example, 10 kilometer is a scalar quantity. 10 kilometer east, if I specify the direction, then it will become vector quantity. Again, moving to the next one, speed. What is speed? What do you mean by speed? In class 6 we have learned speed of an object. If one object is moving, if it is under motion, surely that object will be having a speed. So speed means the distance, that's the ratio between distance and time. So if I am considering 10 meter is the distance I am traveling by 2 seconds. So what will be my speed? 10 by 2, 5 meter per second. In 1 second, I will be traveling 5 meter. So like that we are able to find out speed. And speed is denoted by small letter v, and distance is denominated by small letter s, and time is denoted by small letter t. Then again, if it is a speed, surely there will be uniform speed and non-uniform speed. What is uniform speed? Uniform speed means if the object is moving same interval, that means same distance will be, time interval will be same and the distance covered will be also same. That is called or if I can say that if in 1 second 1 meter is travelled in 1 second. So what will be it will be in uniform speed per second. How much? 1 meter will be travelling. Each 1 second 1 meter will be travelled. Or if I am considering that 5 meter per second, then every 1 second 5 meter will be covered. Then I can say that it is a uniform speed. Then another one is non-uniform speed. What is non-uniform speed? The time intervals sometimes it will be same. For example, 1 second object is traveling. First 1 second it is traveling 2 meter, and the next 2 second what will happen? It will be traveling sometimes 4 meter. Otherwise, sometimes the distance covered will be same 2 meter, but the time taken will be different. First 2 meter sometimes it will be taking 1 second, and the next 2 meter sometimes it will be taking 1.5 second. So that is also non-uniform speed. Again, the last topic is average speed. But how you are going to calculate average speed? Average speed of an object is total distance travelled divided by total time taken. Total distance travelled divided by total time taken. Here you have to remember that average speed can be calculated if the body is traveling with non-uniform speed. If the body is traveling with a non-uniform speed. So for example, we can say that one body is traveling at a first second, in 1 second it is going to travel, or first 2 seconds it is traveling 10 meter, next 3 seconds it will be traveling 20 meter. So average speed will be total distance. First was 10 meter, then 20 meter. Then here it was traveled 2 seconds. Here it was taken 3 seconds. Okay. So like that we can calculate the total distance traveled divided by total time. So we are going to sum that one. 10 plus 20, 30 divided by 3 plus 2, 5. There you can find out the average speed of an object. Okay. Okay. We are moving to the next set of terms. First one is velocity. What is velocity? Definition is, velocity is the distance traveled in unit time in a given direction. We were considering about speed. Speed was distance traveled in unit time. Here in velocity we are just specifying the direction also. So velocity of a body means distance traveled in unit time in a given direction. In a given direction. And can be placed by displacement by time. We can write displacement by time will give the velocity, and the unit will be meter per second, because displacement is in meter and time is in second. So meter per second is the unit of velocity. In velocity also there is uniform and non-uniform velocity. Uniform and non-uniform velocity. In uniform velocity, if we are considering about uniform velocity, when we are speaking about uniform velocity, if the object is traveling or covering same distance in same interval of time without changing the given direction, that is called a uniform velocity. In uniform speed, we have said that equal distance will be traveled with the equal interval of time. Here uniform velocity means equal interval of time, equal distance will be traveled without changing the specified direction. That means if the object is traveling towards north, it should be traveling towards north only. If the body is traveling towards north, and if it is the same distance is covering with the same interval of time with another direction, south or east or west, at that time it will not be considered as a uniform velocity. Then the non-uniform velocity. In non-uniform velocity means actually 3 cases are there. First one, unequal distances in equal interval of time in a given direction. Direction is not changing. Time, interval of time is also at the same, but unequal distance. Sometimes 10 meter. First 1 minute 10 meter towards east. Second 1 minute 20 meter towards east. Then another 1 minute 30 meter towards east. So direction is not changing and the time interval is also not changing, but covered distance is going to be changed. Then that is called a non-uniform velocity. Then again, equal distance in equal interval of time, but its direction keeps changing. That means the distance traveled 10 kilometer in 1 hour, next 10 kilometer in next 2 hour, 1 hour, then again the next 10 kilometer in next 1 hour. So time interval is 1 hour and the distance also same 10 kilometer. But what happens? The direction changes. Sometimes first 1 hour it will be traveling towards north, then it is going to change into south, then it is going to change into west, like that. So at that time also it is called a non-uniform velocity. Then third category is unequal distances in equal intervals of time, and also the direction keeps on changing. Time interval is standing same, but the distance is changing and the direction is also is changing. Unequal distances and not proper direction. Direction also continuously changing. Then also it is called a non-uniform velocity. Now we are checking the difference between speed and velocity. What are the differences between speed and velocity? In speed, distance traveled per unit time. Speed is distance traveled per unit time, whereas velocity is the distance traveled per unit time in a given direction. There will be direction will be specified. Again, Already we have learned what is scalar and vector. Here we are not mentioning the direction, only magnitude. So speed is a scalar quantity, whereas velocity is a vector quantity, because along with magnitude we are expressing its direction also. So it is a vector quantity. Then speed will give only how faster the body moves, whereas velocity will give how faster the body moves along with what, in which direction. So both will be given, how faster it will be given and what is the direction, both will be given. These are the differences between speed and velocity. Distance traveled per unit time, where distance traveled per unit time in a given direction. Then speed is a scalar quantity and velocity is a vector quantity. Then speed will give or express how faster the body moves, where velocity is going to tell us how faster and in which direction. Both information we will be getting. So these are the differences between speed and velocity. Then again, moving towards the last topic of our chapter, two terms, mass and weight. Mass and weight. I am sure that last year we have learned this. In class 6 we have learned this. So what is mass? Mass is the amount of matter contained in a body. Mass is the amount of matter contained in a body. Matter means the small molecules are there, arrangement of molecules are there. So how many number of molecules are there? That is called mass. For example, if I am taking this duster, in this duster sometimes 1000 molecules will be arranged. So 1000 will be the mass, where weight is the amount of force by which earth is going to attract the body. Suppose if I place the duster on my palm, how much gravitational force you already know. All the objects in the universe are, or in the surface of earth, is attracted towards the center of the earth. So if I place this duster on my palm, surely this duster will be attracted towards the center of earth. So how much amount of force is acting on this duster by the attraction of earth is called the weight of the body. And SI unit of mass is in kilogram and weight is in Newton. Last year we have learned about force, chapter force. So this is amount of force. So the weight, the unit of weight will be Newton. Then again, how we are measuring the mass? Mass, in order to measure the mass, we have beam balance, then physical balance, and electronic weighing machine is there, spring balance is there. See, beam balance is there, then physical balance is there, then nowadays we have a electronic machine, weighing machine is there, spring balance is there. So in a simple beam balance or a physical balance, so in order to find out the mass of the object, we will be depending upon either in the beam balance or a physical balance. Whereas in order to find out weight, we are having either spring balance or nowadays weighing, electronic weighing machines are available. Now see, what is the spring balance? For spring balance, we are having top side there is a ring is there, then a metallic case will be there. In between this metallic case, there is a small slit is there, that means a gap is there. Then a pointer will be there, and the bottom side there will be hook will be there. On the hook we can tie any objects. And normally this spring balance we have to, sometimes we will be catching. So normally the range will be very less. Sometimes 0 to 1 kilogram or 0 to 2 kilogram. That much only will be there. And if you are taking a stone piece and if you are tying on a hook, what will happen? This pointer will be pulled down. There will be a spring inside. The pointer will be pulled down. If the pointer is showing 150, 150 will be the kilogram force, will be the weight of this object. So this is about the spring balance. Okay. Now the last set is the differences between mass and weight. Differences between mass and weight. What are the differences? First one, mass is the amount of matter contained in a body. How much amount of matter is there in a particular body will give you the mass. What is weight? Force by which it is attracted by the earth. How much amount of force by which this is going to be attracted by the earth. Then mass is a constant quantity. For example, I have already explained about this duster. So if I if I calculate the mass of this duster, suppose 1000 molecules are there, this is a constant. It is not going to be changed. It will never become 999 or it will never go beyond 1000. But weight is it changes from place to place. Weight will be maximum at sea level. Weight will be maximum at sea level. And if you are taking the same duster to on the top of the Everest, Mount Everest, what will happen? When the distance increases, the gravitational force decreases. So at that time, the weight can be changed. Then the mass can never be zero. That means the number of molecules will remain same. If there is no number of molecules, means no mass, means this object will not exist. But mass can be zero. When we are taking this one into very high, then this gravitational force will become minimum and can be zero. Okay, then SI unit of mass is kilogram and the SI unit of weight is Newton. Newton is the unit of force. Then the mass is calculated or the weighed by find by B balance or a physical balance, whereas weight is calculated by using a spring balance. These are the differences between mass and weight. Okay, then for you a small homework is there. Only a small filling the blanks. You have to write down on your copy and you have to find out the answer. First one, dash is the ratio of the total distance travelled to the total time taken. Dash is the ratio of the total distance travelled to the total time taken. Second one, the distance travelled by a body is a dash quantity, whereas its displacement is a dash quantity. You have to specify whether it is a scalar quantity or vector quantity. So again, the distance travelled by a body is dash quantity, whereas the displacement is a dash quantity. Then third one, if a person walks 10 meter due south, then in 10 seconds, 10 meter east in the next 10 seconds, and 10 meter north in the next 10 seconds, then has a dash velocity. Which type of velocity? Whether it is a uniform or a non-uniform velocity. If a person walks 10 meter south in 10 seconds, 10 meter east in next 10 seconds, and 10 meter north in the next 10 seconds, then he is having dash velocity. Then fourth one, if object covers dash distance in dash intervals of time along a straight line, it is said to have a uniform motion. If an object covers dash distance in dash interval of time along a straight line, it is said to have a uniform motion. You have to find out. The last one, dash of a body is the distance travelled by it per unit time, whereas dash is the distance travelled by it per unit time in a given direction. Once again, the last question, dash of a body is the distance travelled by it per unit time, where its dash is the distance travelled by it per unit time in a given direction. This is all about our chapter. So when you are getting time, you go twice or thrice our class and make sure about all the terms what we have expressed here, the differences what we have expressed, and do this homework. Thank you.